Hi, my name is Lynne Talley, and I'm a member of both the GO-BGC and SOCOM teams. And my topic for this morning is cruise planning for deploying floats. So I'm at Scripps, and we have a team of people that do the shipboard support. Make this work. For deploying, we have a tension basically between the objectives we're observing and then what we can actually do in a given year. Our objective, as you can see on the top left, is to get a completely global coverage of biogeochemical Argo floats. It's a set of random dots in that map, and that's intentional. Basically, by the time we're done, that's more or less what we'd like, and that will cover all of the important oceanographic regimes. To get there, we get there from zero, or not zero, but just a good coverage in the Southern Ocean and some floats elsewhere. We have to take advantage of cruises of opportunity, and that's represented by the GO-SHIP network of sections in the top right, each of which only goes out every 5 to 10 years in its spot. And we also have to take into account how many floats we have available at a given time and where we can get them shipped to. So as we're building out the array, we want to make sure that as we go to each region that we can access by a ship, that we're doing a great job of covering oceanographic regimes. We want to define what those are, what are the properties that are most important to measure there and sample over the long term. And then we want to make sure to deploy in each of those important regimes and maintain the array density after we've gotten started. So we've got some experience with this in the Southern Ocean. This is with the SOCOM program. Starting in 2014, we had very, very few floats. There were a few out there that were developmental. Put in an initial set, and then over the years since then, the 7 years, we've deployed a total of 204 biogeochemical floats. That middle map shows you where they were deployed. So you can see the outlines of the cruises, each of them going here and there. There were actually 33 different research cruises of opportunity that we used to deploy that set of floats. And I want to say how incredibly appreciative we are of everyone who helped us with that in organizing that we could get floats out on ships. Almost all the ships had support measurements that were very useful for our program. After 7 years, we have 115 of those 204 are operational. We have a gap that came out because of the COVID problems last year with getting cruises to sea and being able to maintain the array. But we'll be building that back over the next few years. On the right, you can see our array. The white dots are the currently operating floats. So you can see with that spoked array of research cruises, we've got pretty good coverage. You can also see that there are places where the floats are starting to aggregate, especially in the Antarctic Circumpolar Current, and other places where they sit and just measure for a very long time without going much of anywhere. These are really important things to keep in mind as we're maintaining the array, and to some extent as we put in the original sets of floats. So what are our objectives? This is how we decide where to go and how many floats to put where we're going. We'll start just by saying our objective is global deployment, global coverage. Within that, we want to be representative of all of the open ocean biogeochemical regimes, those that govern carbon, oxygen, nutrients, and productivity. We want to be able to measure the annual mean signal, be able to describe the seasonal signal, and begin on the interannual signals as time goes on, and set a baseline for decadal and longer observations. Our hope is that this will become a sustained array, just as the core Argo array is for temperature and salinity. We want to make sure that we have enough instruments in every regime to look at interactions between different elements of the biogeochemistry and how they interact with temperature and salinity, how the physical processes affect them. So some of the things you could look at, you can make your own list as you try to decide where to put floats, is temperature and salinity and sea ice and other physical properties. We want to look at existing maps of air-sea fluxes because that's something we want to be measuring. We want to look for fronts, which separate different processes. We can characterize the ocean in terms of biomes. This is a machine learning approach that looks at information that's already available. We can look at satellite maps of pretty much everything. I didn't list them all, but temperature and salinity for sure. Chlorophyll, particles, eddy fields, you name it. These all help us decide how to which big areas we want to lump together to make sure that we have coverage. And as we cross frontal regions or boundaries between the regions, that we have gotten floats into each of them. In the long term, we care about ocean acidification. We want to look at how carbon signal is emerging in the ocean. We might want to try to start looking at anthropogenic carbon. We want to look at important problems of deoxygenation and changes in productivity. So here's an illustration of some of the fields that you might look at as you try to decide where to put floats. This is just looking at the phenomena themselves without then also looking at how sampling works. So top left, air-sea carbon flux. We're looking at carbon in the ocean. We want to know what the surface fluxes are, and we are calculating them now from floats. This shows you the global map of uptake and outgassing by the ocean. On the top right, you can look at the field of chlorophyll and be very interested in what the vertical structure is underneath that satellite measurement. You're finding in a lot of places that there's a deep chlorophyll maximum, and so you're only seeing the top of the ocean with the satellites, and it's important to look at how it works underneath. Down on the bottom left and the bottom right, we're looking at how the ocean changes. On the bottom left is anthropogenic carbon based on decadal repeat hydrography measurements. This is from Gruber et al. And you can see the regions where there is excess carbon due to the excess in the atmosphere. So beginning to look at the uptake of that into the ocean. Big subtropical regions in both northern and southern hemispheres that will be super important to make sure floats are in. And on the bottom right is a map showing deoxygenation of the world oceans. Very important tropical regimes and coastal regimes. And we can look at emerging acidification signals and changes in carbon. On the left is from Sarah Schleniger et al., which is submitted, showing the emergence of basically an acidification signal with different emission scenarios. And you can see regions of the world where acidification is underway or will soon be occurring, or can be held off by changes in fossil fuel use. On the right, some model results. These are all model results, which are very important for informing the array design here. On the right is emergence of changes in the DIC and PCO2 from Keller et al. 2014. And here you're seeing the subtropics again emerging as important, as with the anthropogenic carbon map on the previous one. So these give us an idea. There is a lot of regional variability, but there are these big scale patterns. We want to make sure we've got floats representing each of these regions sooner rather than later. In SOCOM, we've been using sort of phenomenological approaches up to now for deciding really where to put floats. A lot of our cruises go from north to south, so we're crossing all of the regimes of the Southern Ocean, or we call them zones, crossing the Antarctic Circumpolar Current, all of its multiple fronts, and on into the sea ice. One of the ways that we've just been deciding to deploy as we go south or north across the fronts is to make sure to hit every frontal zone with a float, if at all possible. And hopefully generally we've had enough floats on those cruises to do that. You see on the left what the array was a few years ago that was used by Allison Gray et al. To look at air-sea carbon flux from the floats. And you can see in the middle how that's filled in with a most recent air-sea carbon flux product coming out of SOCOM. And on the bottom right, one of the ways that we've used to visualize where floats might end up in all these regimes, I'm using Argo trajectories. This is very basic, just find the data set and plot them all and see where they end up. And it does trace out the regions pretty well that we want to make sure to get floats into. We can also begin to decide about regimes for deployments using machine learning. On the bottom left from Ardina et al. On biomes using satellite data. See lots of complexity in the Southern Ocean, but there are distinct bands and regions, and these tend to have different processes operating. We want floats in those regimes. And on the bottom right is using Argo, temperature and salinity. This is by Russo et al. To just let the floats inform us of how they cluster together. And it lines up very well with our traditional zones for the Southern Ocean. And you start to see some differentiation in the subtropics. So this is a powerful way. Both these approaches are powerful ways to look at the global ocean as we start in with global biogeochemical Argo. We have some questions that we have actually. It's a vigorous area right now. Is observing system design. Basically, SOCOM has proceeded in previous projects by saying, let's just look at the properties and go and deploy in those areas that we know have different processes. But we could take that a step farther and go into using models and observations to come up with optimal designs. And this shows, for instance, if you use all of the Argo floats, you can get a field where sort of the darker blue colors are where it's well mapped with a lot of profiles. And you're mapping oxygen using its relationship to TNS to map on the bottom left, on the left, and on the right is if you mapped with only the oxygen itself. So one of the things that comes into saying we only need 1,000 biogeochemical floats instead of the 4,000 that are out there for core Argo is that we build on that core Argo and the relationships between the properties, biogeochemical properties, and the temperature and salinity. So it isn't necessary to sample at the highest density of core Argo. And it does rely on core Argo maintaining its strength. And these are just examples of planning tools. On the left, again, just taking Argo trajectories. This was just making a map. You see the black box down the middle there. That's our recent cruise that we deployed GO-BGC from. It's one of the ghost ship cruises in the western North Atlantic. And the box just looked for every Argo trajectory that went out of that box. And that gives you an idea of what area you're going to basically illuminate with the floats that you deploy. Of course, there are many more floats in there than the number that we deployed, so any given float is not going to illuminate that much space. And on the right is work from Paul Chamberlain et al. To take Argo trajectories like that and construct a PDF of where the floats will go, based on previous trajectories. And so this is a view out 240 days from putting that Argo float in that box in the middle there, basically along that line. And you can see the areas that float might end up in. You can visit this tool in one of the Argo nice visualization tools, and a place to find data, find APIs, find different ways to do all kinds of things, called ArgoViz, courtesy of Donata Giglio at Colorado. And this is in there as a tool. So that's a very quick overview of how we're proceeding to decide where to go. Operations themselves, here we go. Getting into the ocean. We start out by assessing our needs in different regions, and then we use those program objectives and information about what's already out there. And then we start identifying cruises. And this is basically just finding all the resources we can, find out what's happening next year. A lot of it is word of mouth. So One of the things we're asking all of you who are online here is to help us find cruises, help the community find cruises if you know of ships going in regions we need to deploy. We need research ships who have with personnel aboard who can coordinate the float deployments. We're using research ships by and large instead of charter ships because we like to have support CTD and Rosette operations for these biogeochemical sensors. It's not absolutely necessary, as I'll show in the next slide, but the support measurements are important to establish the usefulness and credibility of the calibrated measurements. And so to that end, it's great if the ship is doing biogeochemical sampling already, for instance in GO-SHIP, or in the cruise that Barney Balch there on the right just ran in the South Pacific. We want to measure oxygen, nutrients, and carbon parameters if possible. And we can send somebody to join a cruise. If you happen to have a cruise that's going out and you want to have someone aboard who's taking care of the floats, rather not designate your own person, and you have a berth, we can send someone and they can happily join in your own sampling and be part of your work. So first we're going to start by assessing what we've got. This is the OceanOps map of biogeochemical floats, showing all of the floats that are out there currently in May. Colors are the types of sensors on there. This is a static map. There are other ways to create maps in OceanOps. This is one that you can just easily download. There isn't a sense, though, from this map of whether sensors are operating, and that's actually really important for some of the different sensors are more fragile than others, and so we may have 100% coverage in fluorescence and backscatter, but we're not quite there on pH, for instance. And you can also look at maps of where there are nitrate sensors, for instance. Here you're seeing our SOCOM effort in the Southern Ocean south of 30, plus important efforts from Australia and the UK and France. And you start to see the beginnings of full biogeochemical Argo in the north. Another thing we assess as we decide where to put floats is this is something that Core Argo, of course, has been doing for a long time now, is looking at the age of the existing array. This is a map of the projected ages almost a year from now, next March. And that helps us decide where there might be holes emerging. Black means that there's a dead float. So you basically want to look at the colors. Where they're in the greens and the yellows means that they're not going to last a lot longer. Blues are the ones we just put in. So this is just a helpful tool. I won't talk more about it really, but you can take it and say, well, we have needs in all these areas. Well, it's a lot of areas. So we're looking for cruises in all sectors. And for the rest of the ocean, for GO-BGC, we're looking for cruises pretty much everywhere. This is a word about what we use the ships for. So we probably already covered this in a previous guide, but float calibration and validation, this is true cal-val. The calibration of a BGC float, which is on the top left there, is done independent of shipboard measurements. It's not independent of all shipboard measurements. It relies heavily on climatology based on high-quality shipboard measurements, but it does not rely on the measurements made at exactly the time of the float deployment. That data can go into that climatological database, and it often does. Illustrated, there are two papers here that are important on this, one Johnson et al. And the other is Maurer et al. Maurer et al. Is now submitted that talk about the calibration methods. So basically, calibrating all sensors, starting with an oxygen calibration, it's assumed that the float can surface all the way up and collect an air sample for oxygen. And that is the sort of independent measure then that the float oxygen is calibrated against. Once you have the oxygen calibrated, then we use regressions based on GLODAP, that's that climatology of very high quality data. Those regressions to calibrate the nitrate and pH sensors. The fluorescence and backscatter are calibrated based on basically factory. They come from the factory and get put in the water. and they hold up solid. The bottom shows what we use the shipboard measurements for. You'll see each of these, there's oxygen, nitrate, and pH, looking at float oxygen versus bottle oxygen. So this is the first profile from the float versus the bottle oxygen data taken at the time of deployment. So I said we've put 200 floats in the water, probably 180, 190, maybe 190, have profiles of biogeochemistry like this. And so we have the data points for the vertical profile and from the ship and from the float on that number of floats to do these. And this then gives us a good sense of how good the calibration is of the float sensor. So you see they're doing well, and you can find the assessment of the accuracy in these various papers. Operations, we go to sea preferably with a research ship that has a CTD Rosette operation, so we can do that validation work. It's not essential. We can calibrate without it, but we prefer to have it, especially in areas where there hasn't been great biogeochemical measurements before. We ship the floats off to the departure port. The float engineer comes to the port. So in SOCOM's case, it's an engineer from University of Washington. GO-BGC will include engineers from Woods Hole and Scripps. Check over the floats, reject any that are not working, send them home, load the floats on the ship, and then give instructions to the people on the ship who will be deploying them about cleaning the sensors and how to handle the lines. And then we communicate pretty much from beginning to end of the cruise with our deployers. We have a deployment manual that we put together through SOCOM that describes procedures for the University of Washington group, and there's the link. The other, basically the other manual that we have, the courtesy of SOCOM again, is for shipboard measurements that support these biogeochemical sensors. So we have quite a long manual that describes our HPLC, POC, oxygen, nutrients, pH, and alkalinity sampling. It includes some sample log sheets, includes ways to pick a vertical sampling if you haven't done it before or you're in an area you're not too sure about. And then information about how to ship samples back to us if you're working with us. And there's some pictures down on the right that come from the manual. For GO-BGC, we have a commitment to making HPLC and POC measurements on as many float deployments as possible. We are backing off from the oxygen and nutrients and carbon measurements. HPLC, POC, there's a need for basically global coverage of a relatively new database. And that sampling and analysis is supported by NASA. After a ship has finished its cruise and the floats are in the water and the floats are reporting their data, which you'll hear about from other people in this session, we then have a shipboard data set to manage. And if most of the data are collected by other groups, some of it we sample and run our own analyses. So we have procedures for ingesting the data and merging them, quality control, and then archiving. And our two primary archives for BGC Argo support are the CCHDO, Carbon Climate Hydrographic Data, I forget what the O is, at UCSD. This supports all GoShip, but it supports many other programs as well. It's a cruise-based data set. If you go on CCHDO, you can search for SOCOM, and up pop all the cruises related to our float deployments. And there's a little map at the left. Actually, it shows where ships have gone that have deployed SOCOM floats. Top right is the NASA CBAS archive. It's minuscule, you can't read it from here, but we also have our data sets organized by project name SOCOM. And we'll be setting up a new group in both data archives for BGC Argo going global. So how do we get the floats into the water? Here we go. This is from a recent cruise. This is on the Palmer last season. We didn't get very many in, but we got some in, courtesy of Palmer and and Ravel for having, and for everybody that went on them for their long quarantines before they went to sea. In both cases, steaming a long way to their operations area and then doing all their work and deploying a few floats for us on the way. Whoops! Oh, I'm going to skip this, but it's fun. You just see it go in the water. If you wait long enough, you see it right itself. But there's a deployment of a Navis float. This is a Seabird float. And off it goes. A few minutes later, it actually went vertical and went down. So how do we find cruises? This is it's a bit challenging, but it's something we do all the time. Word of mouth, number one. Just who we know is going where. In each region of the ocean, there are different institutions that often operate. And so working in the Southern Ocean for a number of years now, we have a number of close collaborators for research cruises. We work with cruise planning and program managers. For instance, in the U.S. with UNOLS and with NSF program managers who know that they're supporting a program somewhere. GO-SHIP down in the bottom left is our one of our central ways to get floats out there, but again, it's not very frequent. So any GO-SHIP cruise that goes out, we hope will have BGC Argo floats on it. Because these collect the highest standard accuracy measurements for biogeochemistry, and they go to regions of the ocean that many other ships don't reach. You could look, as I did on the bottom, on the right, for all of the ships that have underway PCO2. This is in the SOCAT network. This is for 1 year, 2019. It gives you an idea of where ships are operating that have some level of CO2 type measurement. We don't use the underway PCO2, but we certainly link it if it's available from a cruise, so you can match it up with a float deployment cruise. Just practicalities. This is just a little list, a bulleted list. We always need close coordination, support with the chief scientist or the vessel operating agency. So different cruises operate different ways. If a chief scientist is their project, we've had excellent support, and vessel operating agency in the U.S., for instance, from the U.S. Antarctic program. We need to have enough floats to meet the departure dates, and so that's always a good point of matching things up. We have to have accessibility to the ports for personnel. This is because these very precious, expensive floats, better to put them in the water only after a dock check. They've been shipped a long way, and in some cases, and they all work before they're shipped. They don't all work after they're shipped. And so this has turned into a major headache for getting floats out this past year and this upcoming year, is that ports are not all accessible. A fourth ongoing one that's been a problem for a long time is that you may think you have a perfect cruise from a perfect port, but actually there's pretty high customs duties on floats entering there. And for SOCOM and now for GO-BGC, we really do not want to pay. We don't have the budget to pay that. So we have to adapt the deployments to cruises out of countries where we don't have to pay additional duties. There are one of the challenges is that there are areas where there are very few scheduled cruises, and as we try to fill in globally, we may, number one, relax our expectations for coincident shipboard measurements. Core Argo was doing this. They charter the U.S. Argo program charters the Kaharoa for big areas of the South Pacific and South Indian that would otherwise get no Argo floats. So we may have to resort to that with BGC Argo and count on our GLODAP climatology and that air oxygen measurement for calibration. And if we absolutely are pushed to it, although this is still under debate, it may end up being necessary to send floats without that engineer backup, but we really prefer not to go there. This is an example of our planning for this year and next in the U.S. This is a combination of SOCOM and GO-BGC planning over the next till about March or April. The purple boxes at the bottom actually all have issues because of pandemic. Either port accessibility is either not accessible or their accessibility is unknown at the time when the ships are scheduled to be there. So it's an ongoing process. We have to be flexible, very flexible, and keep looking for as many cruises as we can. So there we are. I'm at 30. I was given 30 to 40 minutes here. There's another sort of just laundry list of things that one does in planning and executing a cruise. Once you've identified the cruise, then we have a point of contact. That could be the chief scientist, or it could be the agency, or someone else on the ship who's very involved with the program. So we identify and we start communications. We get involved in the cruise organization as early as necessary, sometimes a year ahead. For Antarctic programs, that's been important to be part of that. We keep an eye on the dates and the ports and how many floats we've got. And then we work hard on float deployment locations given what we know about the cruise itself. So the coordination with that point of contact is to know where the ship is going and where they may be doing measurements. And that's important for us to select our float deployment locations. We'll want to know what they're measuring, what they're not measuring, whether we might provide some backup support for the measurements. We prefer to get a full set of measurements, and if it's not going to be complete from the program that's on the ship, we can offer to send someone with equipment to make the measurements. For GO-BGC, that will be additional equipment and filters and so forth to do the HPLC and POC. In SOCOM, we've also been supporting nutrients and pH and alkalinity measurements. These samples come back to shore and are processed at Scripps. We need to figure out what equipment we need to send, therefore, to support whatever measurements, and we identify who's going to take care of us on the ship. It could be someone who's part of the group that's already there, and that's excellent. And we usually have somebody who's very enthusiastic and interested in the program. We can also offer to send somebody out on the ship. And they will be an experienced person. They won't be, they will have been to sea and done this kind of work before. And whether we need to send technical staff, marine chemists, or a CTD operator. That's been rare, but we've done that on several cruises for SOCOM. So then we, in practice, just coming up to the cruise, we ship our stuff to the port. An engineer goes out to check the floats. The watchstander, who's going to go on the ship, if there is one, goes to the port to get on the cruise, joins the engineer to get part of the deployment training. And then through the cruise, we communicate continuously and with our person on the ship. We have, I haven't mentioned in here, a vigorous adopt-to-float program. And so the person going to sea is often really involved with that, and it's working with schools, and there's a lot of decorating of floats and pictures being taken and blogs. So there's a fair amount of outreach as a part of that. Then at the end of the cruise, if we have samples, they come back to Scripps, and if there are analyses to be done, then they're run. And then we have a post-cruise data management that can go on for a couple years as we're pulling in parts of data sets that aren't necessarily ones that we collected. And that's fine. We appreciate everyone's help. So here's where we are. This was the map today. You can find this on the GO-BGC website. We have 12 GO-BGC floats in. There should be a capital O. And we've only been in the water since it's March. And those gold dots in the Atlantic are the GO-BGC. 11 are operational, and one that passed all of its checks and dock checks unfortunately failed. But the other 11 are moving on out from their straight line deployments already. And in the Southern Ocean, over the last 7 years, we put in all those dots, and the white ones are the ones that are currently operational, and the cyan ones are the ones that have reached the ends of their lifetimes. So that's pretty much it. We've got floats out, and the whole world will look like that Southern Ocean soon. This was just a bunch of dot bullets, but the needs. We're always looking for cruise opportunities, especially ones that have the BGC shipboard support, and especially ones going to places where we need floats. For GO-BGC, that's pretty much everywhere. And for SOCOM, that's a continuation of the programs that and collaborations we've had so far. My second one is let's get everybody vaccinated and have a healthy planet so that we can all get back to work in and out of all the ports that we know and love. This is really a big hope for the next year or two. Over the summer and in the fall and moving on out, there is a need and a lot of interest in evolving how we do observing system design. And I've got a lot of questions down there, but we hope to start a working group that's looking at that as part of this growing BGC Argo program. So I think that'll end the talk. And thank you very much. This is the first time I've done a curated talk, so this was an interesting experience. And I'll see you all on Monday for a 10-minute summary of this.